word in a dictionary, you can use the same approach. Now, we don't do it this way because if you are to use this approach in a dictionary, what you need to do is you need to have two bookmarks. You need one bookmark to mark the word I'm looking for can still have, this is the first page that can still contain the word I'm looking for. You need another bookmark to mark this is the last page that can contain the word that I'm looking for. And then every time you compare, you use the page that is right between the two pages that are bookmarked. So that's one way to do it manually, is to use only two bookmarks, one to mark the beginning and one to mark the end. We can do the same thing here. We can do it with two variables as indexes. In revision 2, we introduce the two variables that are crucial to this representation. We introduce, or let, whatever you want to use is fine. Let B be the index of the first element in the array that may have the value k. Let E be the opposite, the index of the last element in the array that may have the value k. In other words, we now have the two bookmarks. We have B as a bookmark for the beginning. We have E as a bookmark for the end. Okay. Are there any questions? Are you guys doing okay so far? What that means is, in this particular example, originally B is here, and originally E is over here, because before the first comparison, we don't know which half we can keep. So we have to say the entire array may have the value that we are looking for. In this particular example, the first comparison is here, and we eliminated the portion to the right-hand side, which means after the first comparison, E gets moved over to here. Because the end of the portion of the array that may contain the value is now only this part of the array. After the third, this is the first. After the second comparison, I cannot remember the order now. I think this is the second one. No.
Yeah.
Is that a?
That was no. Oh,
No, it has to be this one, right?
I think it was the left one.
Yeah.
Maybe this one.
Yeah.
That one.
Yeah. So the next time we compare, we use this portion. So that means we must be using the B. We have to move the B so that we say, okay, we know for sure this part cannot have the value that we're looking for. So the first element that can still have the value that we're looking for is going to start in here. And then we move E all the way over to here, and then E move over to here again. In other words, if you look at it graphically, you can see that initially B and E are as far apart as they can to basically say the entire array can have the value that I'm looking for. After each comparison, they get closer. Now, I don't care which one you move. You can move the B to closer to the center. You can also move the E closer to the center. But in either case, the region or the portion of the array that may still have the value that you're looking for gets halved. Are we okay with the representation of using B as a variable, which is an index of the first element of the array that may have the value k, and using E for the opposite? Okay. So with that in mind, I can modify the algorithm quite a bit to make use of these two additional variables. The first thing we can do is to try to restate. How do we say that we are eliminating everything from the left? The left is, by the way, the beginning, to A bracket M. And this one is eliminating everything from A bracket M to the end of the array. Let's look at this one here. Are we going to change B, or are we going to change E in this case? We are eliminating everything from the beginning of the array all the way up to and including A bracket M. Are we moving B, or are we moving E? We're moving B because we're moving where is the beginning of the portion of the array that may still have the value k. So that means we have to move B here. The most intuitive way is to say, let's make it M. But that would be incorrect. Why is that incorrect?
Because M is one element, B is a range.
No, it is not, because
It would eliminate the one that you just checked.
that is correct. Okay, the reason why we don't want to use B gets M is because by definition B is the beginning. Okay, it's the index of the first element that may have the value k. Don't we already know that A bracket M does not have the value k because of the comparison? So that's why you have to move one step or one element beyond A bracket M, which means B has to be updated as M plus 1. Because we already know A bracket M itself does not have the value k, so the first one that may potentially have the value k is the one at index M plus 1. Well, that makes the other one pretty easy, because if we are moving B in one case, the other one must be moving E. It must be moving the end. And if one is saying that let's move one past index M in this direction to the right hand side, the other one must be saying move past that element, but in the opposite direction. Is that making any sense? It's somewhat symmetric. Are there questions? No?
How does it eliminate?
Say it again? Sorry.
We told the original instructions say to eliminate everything. And we've made B equal to a value and E equal to a value, but how does that eliminate anything?
We are moving the bookmarks that marks the beginning and also the end of the portion of the array that may contain the value k.
So B and E are the bookmarks themselves.
Yes.
Okay.
So we are moving the bookmarks. Everything between the bookmarks may still have the value k.
Got it. Okay. I'm with you now.
Yep. Because this is far less expensive than moving anything within the array itself. We're just moving two bookmarks.
I thought we were actually moving what was in the array. That's why I was confused. I get it now.
Okay, very good. So now we have just simplified the algorithm quite a bit here. Question? No? Okay. Do we have any way to say that the value is confirmed not to be in the array now that we have B and E, one representing the index of the first element in the array and one marking the index of the element, the last element in the array that may still have the value k? Well, think about it this way. Think about the motion of the bookmarks B and E. B starts all the way from your left-hand side, and E starts all the way from your perspective, the right-hand side. B only moves in one direction. Okay, if it moves at all, it is always moving to the right-hand side. E is always moving to the left-hand side. Okay, don't you think that at some point they will meet? Yeah, they will meet. Okay, so they keep moving like this. When they meet, and when B and E are exactly the same thing, what is that telling you?
They didn't find it.
Well, not quite. Okay, you're close. Because according to the definition, B is the index of the first element in the array that may have the value k, and E is the index of the last element that may have the value k. When B and E are exactly the same, it tells you that you have one element left that you have not compared that may have the value k. Because now you are specifying a range of exactly one element in the array. But they are the same. Okay, is that making any sense? Sort of?
If we got the example on the board,
Right.
and you moved E over one more to be in line with B, wouldn't you have looked at all the elements within the array?
No, not yet. Okay, let's look at one example. I will do a trace anyway after this, but it is kind of important for us to understand, how to represent the fact that we know there's nothing left in the array that may have the value k. So I'll just give you a quick example. Well, no example is quicker than this is my index, and this is my value. We have, doesn't matter, 7 as the value of A bracket 0. What do you think is the initial condition of B and E in this case? We have one single element. This is a very extreme case of an array, but it does illustrate what happens when B equals to E. What do you think would be the initial condition before we get into the loop? B equals to 0 initially, because we only have one element. That element has to be the first element that may contain the value k. Right? But what about E? E also equals to 0, because E is the index of the last element that may have the value k. When you only have one element in the entire array, it is both the beginning and the end of the entire array. Before the first comparison, I cannot rule out anything, so that means initially both B and E are exactly the same, which is 0 in this case when we have only one element in the array.
But won't that cause a problem if in your array you have repeating values?
No, because in this case we are only using an extreme example to illustrate what happens when you only have one single element. In other words, what I'm trying to illustrate here is when B equals to E, it is not time to quit yet. Okay? When B equals to E, that means we have one last element to compare to. That's the bottom line. Okay.
What happens if you have like an array of 5 elements?
Okay.
And you have 0, 2, 2, 2, 7.
Okay. 0, 2, 2, 2, 7. And what are you trying to find?
If B is indexed at 2 and E is indexed at 3, B will still equal E.
No, because you said B is at index 2 and E is at index 3. So B and E are not the same in this case. B is less than E in this case.
So it's not the value, it's the index.
Right. B is an index and E is also an index.
All right. Now.
Okay. So are we convinced that when B equals to E is not time to quit yet? So what do you think is a time to quit? Okay, normally which one is smaller? Normally B is smaller, but when they are the same, it's not time to quit yet. So what do you think is time to quit?
When B is greater than E.
When B is greater than E. Very good. Okay, so when B is greater than E, then we can say, oh, it's time to go. Does it make sense? If you look at the definition of B and the definition of E, what does it mean when B is greater than E? We are talking about the index of the first element in the array that may have the value k being larger than the index of the last element in the array that may have the value k.
It means you've gone past the end.
That means you don't have anything in the array that may have the value k. Because your beginning is now surpassing the end of that range, so your range does not contain anything in this case. Okay. Is that okay so far? Is it making any sense? Yep.
Could you do an example of, I don't know if it's possible to illustrate that using the line example?
Mm-hmm.
As I'm still kind of confused, because when you're saying if B is equal to E because they have the equivalent amount or lack of space between them and the value we're looking for, I don't see why couldn't it also be the same, like if they were equal to, or it doesn't matter. I'm confused between saying that B and E is equal to 0 and then B and it's equal to E, because couldn't B and E also be equal to like 1, both equal to 1 or equal to 2? Or is it the equivalent scenario?